This is Gail Kovac for Gresham Barlow School District, Summer School, High School Credit Recovery, Geometry, and Learning Target number 12. I can solve for missing side lengths of right triangles using trigonometry. So we just learned about the Pythagorean theorem and how that can help us solve for missing side lengths of right triangles when we know 2 out of the 3 of the side lengths. However, in this case, with these triangles, we only know 1 out of the 3, and the x is the missing value that we need to find. So the Pythagorean theorem is not going to help us here. However, we do have trigonometry that can help us out as long as we know one of the other angles besides the 90-degree angle. So for this triangle here on the left, I've got one side length here that is 12. I've got another side length here, which is what I'm trying to figure out. And I have a reference angle that is 24 degrees. So I can use that and my trig table, looking up the ratios of these two side lengths using the angle of 24 degrees. So let's see, the side length that I have next to this reference angle here is the side length that is next to 24 degrees. That is your adjacent angle, adjacent, A-D-J, adjacent's fancy word for next to. The other side length that I have is the side length that is opposite my reference angle of 24 degrees. It is the other leg of the triangle. It is the opposite side, so OPP for opposite. The one side length that has not been given to me and I do not need to find is the hypotenuse, and I don't really need to do anything with that. I don't have that value. I don't need to find that value. That value is not going to help me. So I have the adjacent and I'm trying to find the opposite. And those are in relation to this angle measurement right here. This is adjacent to 24 degrees, this 12, and the x is opposite the 24 degrees. So if you remember anything about trigonometry, there's 3 ratios between the side lengths of a right triangle. Sine, which is the value of the opposite over the hypotenuse. There's cosine, which is the ratio of the adjacent side to the hypotenuse. And then there's tangent, which is the ratio of the opposite side to the adjacent. So I need to figure out firstly if I'm looking for the sine, cosine, or the tangent ratio. Which one of those uses opposite and adjacent? Because those are the 2 that I have in question. Opposite and adjacent. O and A, O and A. That's got to be this one here. TOA stands for tangent. Tangent is opposite over adjacent. So tangent is opposite over adjacent. Okay, so we are going to now fill in some things. The tangent is in reference to a reference angle of 24 degrees. So I'm going to start out by looking up the tangent ratio as the decimal for 24 degrees. That is my reference angle. Now that's going to be equal to my opposite side, which is in this case x. I don't know what that is. And then that's going to be over the value of my adjacent side. And my adjacent side is 12. That's what was given to me. So now I am going to use my big long chart to find the ratio of tangent 24 degrees. So I'm going to look on the side to where I see 24 degrees. The first column is for sine, the second one is for cosine, and that third one is for tangent. 24 degrees, tangent ratio is 0.4452. Make sure you can see that on your chart. So 0.4452 is the ratio of my unknown x over 12. All right, so now I have an equation with just one unknown and I need to solve for x. My x on this side has been divided by 12. I have to undo divide by 12. So to undo divide, I'm going to times. I will multiply each side by 12. This side of the equal sign and this side of the equal sign, multiplying each by 12, as those will then cancel and I will have x all by itself. Therefore, x will be equal to, and this was on the left side, so I'll just continue to do it backwards here, no big deal, whatever 12 times 0.452 is. So trusty calculator is going to help me out here. 12 times 0.4452. That gets me 5.34 approximately. 5.34. I want to double check to make sure that my answer kind of makes sense, right? My side length over here is 12. This one is my shortest side, so this should be less than 12, and it is less than 12. So that seems pretty reasonable to me. So let's try another one now. In this case, I have my reference angle here that is 51 degrees. Again, I need that reference angle because the Pythagorean theorem is not going to help me here. I only have one out of the 3 side lengths, so I would have 2 unknowns for the Pythagorean theorem. But since I've got that 51 degrees, that reference angle, and again, the reference angle is always on the bottom left. So you always want to orient your triangle so that your right angle is in the bottom right and your reference angle is on the bottom left. That just makes things a little bit more easy, or you can imagine flipping the triangle around so that it looks this way. Now I need to name my sides. I've got one over here that's given to me, this 14. This side length here is across the 51 degrees across the triangle. So this one is my opposite side. Now the adjacent side, the adjacent leg, that one was down there at the bottom last time, but I don't have a value for that one. That's also not my x, so I really don't care about that side. That side's not going to help me with anything. However, this side across here, this longest side right here is across the 90-degree angle. This one is your hypotenuse. It's the longest side of a right triangle. So now I have the opposite value and I'm looking for the hypotenuse. So given my reference angle of 51 degrees, I'm looking for which ratio, is it sine, cosine, or tangent, that relates the opposite and the hypotenuse together. So that would be O and H, O and H, O and H. There it is, it's got to be sine. Sine is the ratio that relates the opposite to the hypotenuse of a right triangle given a reference angle. So I'm going to need to use sine, and sine is opposite over hypotenuse. So let's see if we can work this out now. I'm given my reference angle of 51 degrees, so I'm going to be finding the sine ratio for a triangle with reference angle 51 degrees. So sine of 51 degrees, that I'm going to look up on my table. That's going to be equal to my opposite value. What's my opposite value? My opposite value was given to me as 14. And then my hypotenuse, and my hypotenuse is my unknown, what I'm trying to figure out. So first thing we are going to do is approximate the ratio of the sine of 51 degrees using my table. So under degrees, I'm going to look all the way down to 51. That goes into the next column over, the next set over. And I'm going to be looking under that first column for sine, and it says 0.7771. So I'm going to be replacing sine of 51 degrees with 0.7771. That will be equal to 14 divided by x. All right, I want to get rid of this pesky divide. So I am going to be multiplying each side by the denominator so I can get that x out of the denominator. So let's multiply each side by x, because now that will be gone on this side. So now I'm going to be left with, and we're going to have to continue over here. This one is a little bit more work. So x times, make that a times, 0.7771 will be equal to 14. So now, to isolate the variable x to get it all by itself, I need to get rid of this decimal 0.7771. So in order to get rid of times by 0.771, I'm going to divide each side by 0.7771. Both sides. And let's see what happens here. Now I'm going to get the x all by itself, and x will be equal to whatever 14 divided by 0.7771 is. 14 divided by 0.7771 is about 18, just a little over 18. So it is 18, I'll give you two decimal places here, 0.02, 18.02. So this one was a little bit more work because in this case, the setup happened to put the unknown in the denominator as opposed to the first problem where it was in the numerator. So we had to do a couple steps to kind of get that x isolated all by itself. But if you happened to just multiply 14 by 0.7771, you're going to get a value that's less than 14. And then if you were to stop and think about, well, does my answer make sense afterwards, then you would think, oh, no, it doesn't. I did something wrong. So it does make sense for this hypotenuse to be about 18 because, remember, the hypotenuse is always the longest side of a right triangle. So that value needs to be greater than 14. And it is. It's 18. That seems reasonable. It's not like 8 million and it's not 8. So it's just a little bit over 14. So that makes sense. If you happen to do 14 times 0.771, I'm just wondering what that is. You would have got an answer of about 10 or 11, like 10.8. And in which case you could say, oh, that doesn't make sense because that hypotenuse is supposed to be bigger than 14 and 10 is not bigger than 14. So I think I made a mistake there. So just make sure that once you've done your calculations that your hypotenuse should always be the longest side. And the real trick is to try and figure out if it's the sine, cosine, or tangent ratio that you're looking for. That's one of the most important things. So make sure that you have that handy. You can remember SOHCAHTOA if you need, or I'm not a big person on memorizing, so if you want to use the cheat sheet to try and see which one makes sense, you could absolutely do that. Sine relates opposite to hypotenuse, cosine relates adjacent to hypotenuse, and tangent relates opposite to adjacent.